All right, so let's do a question on projectiles. I'm Mr. Gilbert. A stone is thrown horizontally at 15 meters per second from the top of a 44-meter high cliff. All right, so what do we know here? We know that it's thrown horizontally. We know that it's thrown at 15 meters per second. And we know that the cliff is 44 meters high. What are we trying to find? Question A. How long does it take to reach the bottom of the cliff? So, we've got a rock. It's gotten thrown off a cliff, right? Now, its horizontal velocity is 15 meters per second. But its vertical velocity in a horizontal projectile problem is always initially 0. What happens is that the horizontal velocity has absolutely no bearing on how fast something falls. The only thing that affects how fast something falls is the acceleration due to gravity. So, what we're trying to figure out is how long it takes for something to fall. So we don't even worry about this horizontal velocity. All we're looking at is the distance that it's going to fall. The distance is 44 meters, and it's falling, so it's a negative 44 meters. And then we know that the acceleration it's going to experience is 9.8 meters per second squared. And that's also negative because it's accelerating downward. So we know these two things. And we can look at the formulas we've been given, and we can say, oh, this one might make sense. The distance is equal to the initial velocity times the time plus 1/2 at squared. Like we talked about, in the horizontal direction, the initial velocity is 0 because right at the instant it comes off a cliff, it's not falling yet. So we can say that this is 0. So this whole term gets crossed out. So all we have left is the distance, which we have, the acceleration, which we have, and we're trying to find the time. So let's do that. Let's rearrange. So we have the distance here. What I'm going to do to rearrange is I'm going to divide each side by 1/2 a. So d divided by 1/2 a is equal to t squared. T by itself is equal to the square root of the distance divided by 1/2 times the acceleration. You see what I did there? I square rooted each side, got rid of that, which gets rid of the square on the t, and then the square root on the other side stays. So the time is equal to the square root of negative 44 meters divided by 1/2 times negative 9.8 meters per second squared, which turns out to be 3 seconds. Okay, so we have an answer, 3.0 seconds. So, question B, how far from the base of the cliff does the stone strike the ground? So how far does it go? How far does it go? So here's the cliff, here's a stone. It's going to have a path somewhat like this, right? Because it has a horizontal velocity at the same time as it's falling. So let's figure that out. We know how long it's going to be falling, and we know how fast it's going horizontally. Its velocity horizontally is 15 meters per second. The acceleration due to gravity has no effect on the horizontal velocity. So the whole time it's in the air, it's traveling at this horizontal velocity. So we can use our really easy formula that we should know from a long time ago, right? We've seen it recently, and we've seen it so many times. The distance is equal to the velocity times the time, which is equal to 15 meters per second times 3 seconds, right? So what is that? What's 15 times 3? Well, 45 meters. That's how far it goes from the base of the cliff. So it's going to go from the base of the cliff to where it lands is going to be 45